Hi, my name is Lisber Pontes. I'm a senior principal software engineer at Milestone Systems, and in this presentation I'm going to talk about how to integrate IVA applications with Milestone AI Bridge. Let's get started. We're going to start this tutorial explaining the registration and unregistration of IVA applications. After that, we're going to explore the integration features that Milestone AI Bridge offers to IVA applications. And last but not least, we are going to explore a simple IVA application we called connectivity sample. All right, let's now check how the registration works. So first of all, once the Milestone AI Bridge has been installed and it's registered on a VMS, then the next step is to install IVA applications. An IVA application must at first register itself with the VMS, and for that it must use Milestone AI Bridge. Let's have a look into this diagram that shows a potential flow of registration. In here we can see that we have a Milestone AI Bridge application running. This Milestone AI Bridge is connected in this scenario with one VMS. It is also true that we can connect one Milestone AI Bridge application with multiple VMSs. Then in the right side, we can install an IVA application that could in principle be made of a front end, back end, and an inference engine. At some point, this IVA application should send a registration request to the Milestone AI Bridge through the GraphQL API. In that request, it must indicate into which VMS this IVA application must be registered. Let's have a look and a deeper understanding on how these requests and how this registration works. The registration can be achieved by sending a register mutation to the Milestone AI Bridge API. We thus recommend that all IVA applications should register themselves with the VMS upon start. Let's now check a demo on how this register mutation works and how it could be used by an IVA application. First of all, we have in this machine an AI Bridge installation running. I've decided to install it through a Docker Compose, and in this case I'm running in debug mode because I've run the Docker Compose YAML file instead of the Docker Compose production file. That means that I can now browse the AI Bridge API from outside of the cluster. So I have here the AI Bridge up and running, and now I'm going to go to the GraphQL application. This is the application that we can use to live demo and query the GraphQL and thus the Milestone API. So let's start now by checking what it's in this system. So if we go and check, for instance, which is the management, which are the VMSs to which this Milestone AI Bridge is connected, and also what are the applications that are part of this installation right now. So for instance, I could try to render the ID and name of the applications. But let's see first what do we have here. Okay, so basically this is a clean system of Milestone AI Bridge. It's just connected to a VMS, but it has no applications installed, meaning that there are no applications registered on this Milestone AI Bridge pointing to this VMS. So in order to register an application, we have fully documented in the mutation section the register mutation, and therefore you can find more information about it in this URL. However, for the sake of this presentation, I'm going to register a fake application. The first thing that we will need to do is to, when we register an IVA application, we must select in which VMS do we want this application to be registered. In this case, since I only have one VMS connected to AI Bridge, I will use this ID. So this is an example of a mutation that sends the register to the AI Bridge. And let's just briefly see what's inside. First of all, the ID of the VMS must be set in the ID property. And then in this case, I'm passing a list of application. In this case, it's just one application, one object. I'm specifying also an ID for this application, a URL in which this application can be seen. This URL can be used in the management client for a landing page when browsing the IVA application. We are going to see that in a future demo. We also have the name for the application, the version, the manufacturer, description. You can again find all the details about these properties in our documentation. Last but not least, we are registering two types of topics. This is also something that we are going to discuss in this video tutorial in a further section. And if we run this mutation, this answer and this response means that it has been registered properly, meaning that if we query now the average and we ask for which cameras, or sorry, which applications are available on this VMS, we should get more information. So let's now retrieve the name. In this case, we are getting already an application registered within the Milestone AI Bridge. This application can also be seen if we go to Management Client and we click on the AI Bridge that has been running. We can see here that there is an entry for the demo application, and in here there are the two topics that have been defined, as well as the landing page for the IVA application, which in this case has been set to the Milestone web page. Let's move on now to unregistration. Once an IVA application has been registered with one VMS or multiple, we can unregister it. When we unregister an IVA application, we must send a mutation called unregistered to the GraphQL endpoint. And in that mutation, we must set which is the VMS ID in which we want this IVA application to be unregistered from. Let's have a tiny demo on how can this be achieved. I want to stress again that the unregistered mutation is documented in our GraphQL API. Also coming back to this application, we have here a VMS and an application. So in this case, when we unregister, we must set in which is the VMS that we want to unregister, and also which is the application or set of applications that we want to unregister. So I will just use this mutation that you can see here. The ID is the ID of the VMS, and then the applications is an array collection, and we can pass one or multiple applications. In this case, I'm passing the ID of the application that we registered before. So now that we have run this mutation, the unregistration has happened. And now if we query this information from the Milestone AI Bridge interface, so we go and ask again for this video management system, and we ask for the applications that are inside of it or registered. If we launch this query, we will see that the applications now returned an empty array, meaning that the application has been unregistered. I will register again this application. I will run the command that I ran previously. And I'm doing this because apart from the mutation strategy, we also allowed an IV application to be unregistered from XProtect management client. How can this be done? Let's see. Once we are in Milestone Management Client and we have installed the Processing Server plugin, we select the Milestone AI Bridge that we want to unregister an application from. And from the Register Applications list, we can call Unregister button, confirm the unregistration, and this has exactly the same effect as running the GraphQL endpoint, meaning that if we rerun this query again, there are no applications registered anymore. Let's review now some of the integration features provided by Milestone AI Bridge to IVA applications to use. One of the most common use cases for any IVA application is the need to consume an RTSP feed in order to generate the video analytics. Common streaming frameworks such as GStreamer typically would expect an RTSP feed as an input. So let's take a look now into how an IVA application can get access to the RTSP feeds endpoints from the Milestone AI Bridge. Before doing that, I want to mention that I've modified my existing running installation of AI Bridge to include the scope property. By using this scope property, I can limit the amount of cameras that Milestone AI Bridge will fetch from the VMS. In this case, it will fetch only cameras from the demo camera group, and it happens to have only one single camera. So now, let's go now to the API, and let's start querying information about the cameras. For instance, I want to know their name, their ID, and now let's take a look into the video streams, the codec, and the stream availability. In this case, we have several protocols, but we will explore now the RTSP protocol. After running this query, we can see now that we have an RTSP feed ready for us to use. So if any IVA consumes this RTSP feed from their application, they will have access to the RTSP feed immediately. All right, now let's take a look into the direct streaming protocol. It's a gRPC-based protocol, and it allows IVA applications to get live video, playback video, and snapshots. There is a .proto service definition file available at the reference manual, and the idea is that any application could developed on different programming languages can leverage this .proto service definition file in order to generate the client code that is needed on those programming languages to interact with direct streaming. There's also something important to mention. The video fetched using direct streaming protocol will be stored locally as raw video stream files. So now let's take a look into how an IVA application can take advantage of the direct streaming protocol. First, as we were seeing before, when we are fetching the stream availability out of the cameras, we saw that there was the RTSP property, but now we can also see that we have the DS for direct streaming. When we execute this query, we will see now that we get the connection string that it's needed in order to connect to the gRPC-based protocol. Now the next question is, where is this .proto service definition file available? So as you can see from this query, the stream availability has the DS reference. So if we go to our API and we browse the stream availability, we will see here that there is a reference for DS in here, and there is a hyperlink for the .proto service definition file here. Once you download this file, let's take a look into how is it. You will see that at the very bottom, we have the remote procedure calls, meaning the interface or the methods that we can use when interacting with direct streaming protocol. We have methods as taking snapshots, getting live video, and also getting playback. All right, now let's explore a tiny Golang based application that leverages the proto service definition file in order to create the client code needed to get playback footage. First of all, let's just be sure that we have playback available for a certain camera. In this case, the camera it's 18649. It includes it's included in its name. And as we can see, we have footage around this date and midday. So that's good. Our tiny Golang based application requires some configuration. In this case, we are setting the camera and the stream ID. This information can be obtained from the GraphQL API. In this case, that means that this camera, the one that has 8649 in its name, has one stream. It is possible that cameras can have multiple streams, and for that matter, we create the ID on video streams level. In this case, this camera only has one stream, and that's the reason why we only get one object in this array. So now if we go back to the Golang application, since we leverage the creation of the client code on the proto file, we will see that we have now the client created and the methods are already available to use. In this case, we have the method called playback stream, and it requires the stream ID that we saw before and a starting and ending point in time. So once we run this application, we call it playback. We will see that the footage is being taken out of the VMS and it's stored as a raw video file. Now, if we want to see the content or the video of this file, we could use a demox application. In this case, I'm going to use VLC to extract the video content out of this raw video file. So by running this demox command, we can see now the video that we could extract out of the VMS using direct streaming protocol. And this is quite useful for forensic applications in order to run analytics not live but after the event has happened. The source code of the playback Golang application is going to be shared in our official Milestone public repository for AI Bridge samples in the near future. Let's take a look now into the ConfigMaps functionality. ConfigMaps are useful when an IVA application wants to persist data in the Milestone XProtect database. They work as a collection of key value pairs and they can be set at two moments. One is when registering the IVA application. They can include ConfigMaps in that registration, or they can be set at runtime if the IVA application decides to do so. Let's now explore how can an IVA application can include ConfigMaps when registering. For that, we are going to go back to the API and using this amazing tool called GraphQL. In here, I'm going to use the same registration that I used at the beginning of this video tutorial in which we were registering the demo application. In this time, I will be including some config maps for the demo application. If we run this mutation now, it has been successful registered, this IVA application called demo application. Now, if we want to retrieve the config maps from this application, we can run this query using config map with the filter of the application name. And in this case, if we run this query, we will see that we get the two values that were set when the application registered itself. Now let's take a look on how an IVA application can update, add, or even delete config maps at runtime. To achieve that, there is an update config map mutation defined. So let's see how it works. If, for instance, we want to update a config map, as in this case, we have the my demo app key defined, By running the mutation, passing the name of the application, the key, and the expected new value, it should be good enough. So let's see. It has been updated. Now let's get again the config maps. As we can see now, the value has been updated. So that means that the config map mutation has worked properly. If we decide that we want to add a new value, then it will be as simple as just not having a key that was part of this application. So if we run this mutation now, we run successfully. Now let's fetch the config maps. And as we can see, the new key has been added. In order to delete a config map, an IVA application can just simply set a null value, and that should delete the config map. Let's test deleting this config map. Now let's fetch the config maps. And as we can see now, the config map with this key has been deleted. All right, now let's dive in on this subject, which is a core functionality of Milestone AI Bridge called topics. Basically, Milestone AI Bridge defines three types of topics: event, metadata, and video topics. Then it's up to an IVA application to define its own topics upon registration. And basically what they will do by doing so is that they are exposing and being explicit in regards of which kind of data they offer to the VMS. Then a VMS administrator will subscribe to the IVA application topics that they will want to be allowed to enter into the VMS. And in order to make that subscription happen, they will use the processing server admin plugin that it can be installed on a management client application. Let's take a look now into a small diagram that can help us identify and understand what is the concept around topics on Milestone AI Bridge. So in this small diagram, we can see the fact that an IVA has been registered in the Milestone AI Bridge. And as part of that registration, it's being explicit in the fact that it supports an event topic called fault detection, which in principle could be an event that this IVA application can send back to Milestone AI Bridge informing when a person falls. We also have here a cat classifier. This could be in principle some metadata that the IVA application can generate when it detects and classifies a cat, meaning that they could in principle send metadata or a bounding box around cats that were identified. And then we also see here a blurring faces video topic. That means that the IVA application in principle could fetch the RTSP or the direct streaming video from the VMS, blur people's faces at runtime or playback, and then inject this video back to the VMS. However, none of this data will arrive to the VMS if the VMS administrator do not subscribe to it. So that's the goal of a topic, to define which is the type of data and on which cameras this data can enter into the VMS. Because as soon as an application is running, it can at all times send events, send metadata, and send video to AI Bridge. However, that video, metadata, and events are not going to be available on the VMS until a VMS administrator decides to be injected. And that's the goal of the topics. There is no restriction around the amount of topics that an application can define, whether if there are 10 event topics and 20 metadata topics and 1,000 video topics, there is no limit on that. And it will always be up to the VMS administrator to define on which cameras and which topics are allowed in the VMS. Now that we have seen the concept around topics, let's see how the subscription works within the management client UI. In this case, I'm logged in into a management client application that has the processing server admin plugin installed. And as part of it, we can see now that we have an AI Bridge registered. It is connected. And it also has the demo application as expected because I've been registering this demo application across this video tutorial. This demo application, it's exposing two topics, one of type metadata and another of type event. The metadata topic, according to the description, defines that it can detect cars, people, bicycles, and road signs. So in principle, this type of topic will allow to send bounding boxes coordinates to a certain camera. In the event type, we can see that it can send an event when an object is moving to the south direction, and they call this topic south. Then it's up to the VMS administrator to define on which cameras can these topics be connected. So to do so, they should go into the recording server node. They should decide on which cameras they want these topics to be enabled. And from the right side panel, they should go to the processing server tab and click on which of the topics they will like the subscription to start working. As soon as they define which topics there should be allowed on this camera, they should just press save button, and that should enable the subscription from that moment onwards, meaning that after the VMS administrator press the save button, then if the event or the metadata were sent to the Milestone AI Bridge on that camera, it will actually be allowed to enter into the VMS. All right, let's talk now about the ingestion of events into XProtect. So Milestone AI Bridge allows IVA applications to send analytic events back to the VMS. And in order to do so, it offers three different protocols, which are then up to the application developer to decide which one to use. So when an IVA application requests the topic availability for event topics, we can get REST endpoints, gRPC endpoints, or Kafka endpoints. In this concrete example, we can see that for the topic south, we get a specific REST endpoint, a gRPC, and a Kafka one. That means that from the moment this IVA application wants to send south events back to the VMS, it must use one of these three protocols using specifically one of these three endpoints. We can also see that behavior in this diagram. In this case, we have an IVA application running here, and at some given moment, they might decide to send an analytic event to the AI Bridge. They can use gRPC, they can use REST, or they can use Kafka. It's again up to the application developer to decide which one to use. It's also important to remember that regardless of the fact that the application will be able to send events to any of these protocols, it will always be required for the administrator to accept or to register or to subscribe to those events from management client in order for them to be available, for instance, when defining alarm definitions. All right, what about the format of that analytic event and where can we find the schema? So basically we have exposed the schema of the analytic event in our GraphQL API. So from the moment you browse the event format, you will find references to the analytic event JSON schema. As we can see here, whenever we open the JSON schema, we will have a definition on how an analytic event look like. It's worth to mention that not all of these properties are required when sending an analytic event. But we are going to see in a few seconds a quick sample that shows how to inject a simple analytic event into XProtect. All right, now let's run a small demo showing how to inject analytic events from an IVA into XProtect using Milestone AI Bridge. the first thing we need to do is to go to Management Client and subscribe to a South, in this case, to the South event topic. I want to stress that in regards of event topics, it is not really important from which camera do we make the subscription. Why is that? Because after we subscribe to this event topic, regardless of the camera, what we are going to get is a new analytic event registered in our system. So I'm just going to refresh Management Client. And now that we have subscribed to this South event, if we go to Analytic Events node, we're going to see here now that we have a demo application / South. This is exactly the analytic event that now it's available on the VMS because we have subscribed to that topic from the demo application IVA. That means that from this moment onwards, we can start defining alarm definitions that can be triggered if this event is raised or if we receive this type of events on the VMS. Now that we have subscribed to the event topic, let's create an alarm definition that will get triggered whenever a South event arrives to the system. To do so, I'm going to use Management Client and create an alarm definition. The event that will get triggered is an analytic event, and in this case I want it to be the demo application South. In terms of sources, I'll say that all cameras, I'm not filtering by cameras. So now when I press save, we have an alarm definition that it's going to get triggered whenever a South event arrives to the system. Now that we have subscribed to an event topic and we created an alarm definition, let's explore an application that will use Milestone AI Bridge to inject an event into the VMS. For this simple application, I'm going to use the REST protocol. And what this application will do is sending this analytic event once. And something that it's worth to be mentioned is that whenever we send the analytic event, we must inform about the camera source. And this ID of the camera can be obtained from within the GraphQL API. In this example, I'm going to, besides sending the event, I'm also adding some metadata information and even adding a snapshot with images that are relevant to this South event. In terms of code, what this application does is simply a post into the REST server. And what we are doing is basically injecting the former event. So once we run this application, I will run it from here. It is called REST. So this application is sending the South analytic event to the REST endpoint. If we go now to Smart Client, as expected, we can see that there is a new alarm. Here are the two snapshots that were part of it. And if we call this application multiple times, for instance, one and again, we have called it 3 times, meaning that there should be 3 analytic events in Smart Client. And they are here as expected. We can see that the message includes the demo application South. And now we have 3 alarms that were triggered because the IVA application sent the South event to the VMS. All right, now let's take a look into the metadata topics. So basically, when an IVA application wants to send metadata back to XProtect, AI Bridge offers 3 types of protocols. It allows to be sent on REST, gRPC, or Kafka. And thus, when someone asks for metadata topics under topic availability, they will receive in the response the 3 endpoints that could be used. In this case, these 3 endpoints are related with a topic called objects. And that means that if an IVA application wants to send data to the topic objects, it can use one of these 3 endpoints. In regards of the format, AI Bridge supports 2 main formats. ONVIF, which is an XML-based metadata format. It's an open standard highly embraced by Milestone. It offers direct integration with the smart search on the smart client. We also support on AI Bridge DeepStream Minimal. It is a JSON-based format defined by NVIDIA and used in frameworks such as DeepStream SDK. When the DeepStream is used, there will be a conversion handled by the AI Bridge before sending the metadata back to XProtect, since XProtect only supports ONVIF format, but AI Bridge will handle the DeepStream minimal if it's used by the IVA application. In case someone wants to explore what a ONVIF-based message can look like, we have in the metadata format in our API some examples. So if we click on this example here, we'll be seeing a metadata message. The most important thing are the timestamp, because this will make the association between the metadata and the video. It is also important to set the source stream ID. This is the ID identifier of the camera and the stream used by that camera. Also, something that can be used is this node called class candidate. In this case, we are defining a vehicle. So that means that within this timestamp, a vehicle has been found of this brand and this model. And last but not least, we can also define bounding boxes around the classified object. So that's an example of ONVIF. There is also the ONVIF frame. So this is a subset or a subformat out of ONVIF analytics. In this case, this ONVIF analytics might include more than one frame, whereas the ONVIF analytics frame has the frame as the node. Here is also an example. It's pretty similar to the other one. In this case, we are just defining a frame. Last but not least, we also have the DeepStream Minimal. This is the protocol defined by NVIDIA, and the one that AI Bridge will translate into ONVIF when it arrives to AI Bridge. Here's an example. It's a JSON-based protocol, and there are more information in the web regarding that format. All right, now let's take a look into a possible workflow involving the injection of metadata. So as we can see here, we have a simple application that exposes one topic called cat classifier. It's of metadata topic. It could be using ONVIF, DeepStream Minimal, for example. Then we know by now that this IVA application can use gRPC, REST, or Kafka to send this metadata to AI Bridge. However, it is also important to remember that this data will not fly to XProtect until the VMS administrator do not subscribe to this cat classifier topic for a given camera. So from the moment this administrator of the VMS decides to subscribe to the cat classifier topic for a given camera, let's say for camera A, what it will happen is that a new hardware will be created. It is the VPS hardware that it's going to be bound to this camera. And then from this moment onwards, the VMS will be able to receive the messages that might come from gRPC, REST, or Kafka in the VMS. But this subscription must happen, and this hardware will get created for that to happen. I will also like to stress the fact that the metadata topic should include in its body the source stream ID, because this is the identifier that it's going to be used for Milestone AI Bridge to store the metadata. So it is important that it gets sent in the message. All right, let's now take a look into how this subscription to topics happens on Management Client. So now that we are here as a VMS administrator, I will subscribe to the metadata topic on this specific camera. So I'm going to the Processing Server tab, And from here, I see that the demo application exposes the metadata topic called objects, and it's using the ONVIF analytic format. So when we save this subscription, we get this notification mentioning that there is a new metadata device created. I'm going to refresh now the management client. And this is the metadata that it's related to the camera. So if we go to the metadata node, we will see here that there is a new metadata created. It is called the objects ONVIF analytics metadata, and it's related to this camera. If we also go to the camera and click on Client tab in here, we can get an idea on what are the related metadata devices for that given camera. So as you can see, after subscribing to the topic objects, I got this new VPS-based metadata driver. All right, since we have now subscribed to a metadata topic, let's see how can an IVA application could send this data and be received by the VMS. For that, let's explore a quick sample code made on Go, in which basically we are going to send back and forth these two ONVIF-based messages. Basically, we are adding two different, several object identifications. In this case, are vehicles. And we are also drawing some bounding boxes coordinates around the object that has been identified. This information, we will see afterwards, it's going to be then used by Smart Client to render them and display. Also important to mention that we must always include the timestamp. This information, the timestamp, it's always available from our RTSP and direct streaming protocols. So there will be always available for an IVA to use. And it's also important to always include the source stream ID. This ID is the identifier of the camera and the stream. And it can be obtained from our API if we search for the ID on a video stream, we will get the unique identifier of the video stream ID. Remember, a camera might have more than one stream, so we must always represent the camera plus the stream that we want to use. So once we have the frames ready, we have this simple application that it's going through the Kafka integration, send or produce some Kafka messages, and send it to the Kafka topic on AI Bridge. As you can see here, we are always including in the key the source stream ID. This is also highly recommended. And now let's just run the application and see how it goes. So I'm going to run here the application. It's called Kafka. And from here, the application now is sending the ONVIF 1 and 2 in one at a time. So if we go to management client, to smart client, we can see already that the data it's being represented. I'm actually going to start a recording to then show you the smart search integration, but you can see how the frame 1 and 2 are being sent. Also, we can see in the management client, if we go to metadata, there will be an animation showing that metadata is being received. That's also a sign that metadata it's being or it's arriving to the VMS. But obviously, with the smart client and the bounding boxes, it is quite clear that metadata it's arriving. So I'm going to stop the application, and I will show you now how the integration with the smart search might look like. So if we go to the search, and we select the camera, it's already there. We will have the option for vehicles. And in here, we could in principle select multiple options. Depending on what's inside the metadata message, we could in principle be able to filter by these properties, by color, by type of vehicle, by license plate. So this is all up to the IVA application to send in the message, and then using Smart Search, we will always be able to retrieve that object that has been identified. We have seen the event and metadata topics integration. Let's now dig on the video topics integration. Milestone AI Bridge allows IVA applications to send modified video back to the VMS. To do so, it offers two protocols, REST and gRPC. Kafka is discouraged and has not been implemented since we believe it's not optimal for this type of integrations. When requesting the REST endpoint, we must always pass the source stream ID that we want in order to use REST protocol. This has been documented in our API that when fetching the REST endpoint, we must always include the source stream. And as you can see in this example, I'm just querying video topics for a certain application. And then in the topic availability, I'm asking for REST and gRPC endpoints. But you will see that I'm passing in the source stream the parameter or the filter of source stream ID. When doing so, the REST endpoint that we get, it's ready to go and to be used in order to inject video back to XProtect. Let's see the workflow of injecting modified video through a diagram. In this case, we have an IVA application that it's exposing a video topic called face blurring. The idea could be to modify the video and blur people's faces. In this case, this IVA application could send the modified video to the gRPC or REST endpoint provided by AI Bridge. However, it is important to reinforce that none of these modified video will arrive to XProtect until the VMS administrator do not subscribe to this video topic on a given camera. So once a VMS administrator subscribes to this video topic on a given camera, a new camera will be created in the VMS, and it's through this new camera, using Smart Client for instance, that anyone can visualize the modified video sent from the IVA application. It is worth to mention that from the IVA application development point of view, the reference when injecting the modified video, it's always going to be the source camera. Let's see a quick demo showing how this subscription of a video topic works using Management Client. First of all, I will modify the demo application that I've been running through this video tutorial in order to include video topics. So basically, I'm adding the video topic. It is called anonymized. I'm informing that it's going to inject the video using H.264 codec, and there is a small description for it. So I will register this IVA application. And now that it has been registered, let's go to Management Client. And from here, if I go to the processing server, I'm able to see that there is this anonymized object or video topic. It's H.264 as it has been registered. When we press save, we will see that there's a notification mentioning that a new camera is going to be available. So if I refresh Management Client, we will see now that there is this new camera that has the same name as the original camera, but it includes the anonymized and the H.264 as the codec that was selected when we registered the application. Now that we have subscribed to the video topic, let's explore a sample application that uses gRPC protocol to send video back to XProtect. First of all, it is important to mention that in our reference manual under topic availability, you will find in the section of gRPC the proto file, the interface definition file that it's needed in order to use the gRPC integration. Once you download this file, you will have the broker.proto file, and in this file you will see the remote procedure call definitions for publishing an event, publishing metadata, and publishing video. This means that you can use this proto file to generate the client code in the programming language that you feel more comfortable with and start writing the code to send the video or the metadata or events back to XProtect through gRPC, through AI Bridge. We have built a simple application in gRPC leveraging this proto definition file. And what we are doing, we are sending a group of pictures, a GOPS, which includes iframes and bframes, a combination of them, in order to mimic the video being sent. So basically we are setting the app ID, the topic name, the video codec, in this case H264, because this is what we registered in the IVA application, and then the camera stream ID as the source stream ID. So let's see it live. After we build these codes, I have it as gRPC executable. When we run it, we are sending the GOPS through AI Bridge to the VMS. So that means that in this camera, which is the anonymized camera, there is this live preview that we can see below that it's showing already some video. If we go to Smart Client and we drag and drop this camera as any other camera, we should also be able to see the footage that it's being sent by the IVA application through gRPC. Let's just load the Smart Client and see it live. So I'll be just dragging and dropping this camera. It is here under processing server camera group. So I will drop it here and go to live mode. And we can see here the live video coming out of the IVA application, blurring people's faces. In this case, it has stopped because the application has finished. If I trigger again the application and I start sending the GOPS again, the live video should resume and carry on as it was before. Let's just give it a bit of time, and here it is. So it is blurring people's faces, and it's video coming directly from the IVA application through gRPC. Let's talk now about the connectivity sample. This is a sample application we have made in Golang, and it showcases all sorts of integrations an IVA can do when interacting with AI Bridge. Its source code is publicly available at this URL, and in the first version, it includes functionalities that showcase how to self-register an IVA application, how to obtain snapshots, and how to send analytic events to the VMS. In moving forward in future versions, we are going to add or include how to send metadata and how to send modified video, as it has been shown in this video tutorial. Let's take a look into the official repository. When you navigate to it, you will see that it comes with a fully detailed README file that includes information about how the application works, how to install and how to deploy it on Compose and Kubernetes environments. As mentioned before, we plan to add more and more functionality as we include in AI Bridge and use not only this application connectivity sample, but even building more applications as we go. Connectivity sample is a single container application, and we have published the Docker image in AWS ECR, and we have also published a Helm chart package so that it can be easily deployed on Kubernetes. You can find in the GitHub repository the instructions to run it, to deploy the Helm chart package on Kubernetes, as well as you can find a small Docker Compose file to be used on Docker Compose installations. As mentioned before, this application can be downloaded to date from the public ECR repository that you can see here. And let's have a quick look at it. From here, you will see that we are publishing a Helm chart package, as well as just one Docker image as part of the bundle. We also have a direct link to our GitHub repository and a small definition of the application. Let's check now how to install and run the connectivity sample. As part of the public repository, we are providing ready-to-use configuration files for Docker Compose installation, as well as a Helm chart package for Kubernetes deployment. Apart from these two options, or recommended options, we can also run and install the connectivity sample through a standalone executable. However, this is not the recommended option. And if you want to test this integration using a standalone executable, the Milestone AI Bridge must be running in debug mode. Let's take a look into this diagram to showcase what happens when connectivity sample runs as a standalone binary. Since the connectivity sample in this scenario is running on a host which is different from the host that it's running the average, in this case, it could be a compose or a Helm chart installation. When this happens, the AI bridge must be running in debug mode, since the endpoints and the ports to allow the query, the streaming, or the broker should be accessible from within this host. And this is why we do not recommend this option, because it forces the AI bridge on running in debug mode. Let's see through a short demo how to run this connectivity sample as a standalone executable. So what I've done is that I cloned the connectivity sample public repository. And as you can see, it comes with a README file with all the details needed to install, to build, run, and install this application. It comes with the instructions to run it as a process, meaning as a standalone executable. Also, how to install it on Docker Compose setups, and also how to install it based on the Helm chart that we are publishing. If you follow the instructions, you will see that it is mentioned that the environment file must be adapted. So there is this env file, and it must be adjusted. In this case, the main settings that should be addressed are the external IP and hostname. And these are the IP address and the hostname in which this application is going to be deployed. In this case, I'm deploying this application on Docker Compose environment in this external IP address and with this external hostname. All the rest of the values, they do not need to be adjusted by default. Only the TLS in case the average and the XProtect are running on secure mode. But again, as mentioned before, all the instructions in case that's needed are handled in the README file. So coming back to the README file on how to build the application as a standalone executable, we are providing two scripts, one called build binary and the other one called run binary. So if we build this binary by calling build binary.sh, we will see now that there is a executable in the bin folder of the repo. And since the executable requires some parameters to be injected, we've provided this run binary.sh to call that executable and to pass all the required parameters. So if we call run binary, it will end up calling this executable. As we can see from the message, it says that the registration has been successful, and this is because the connectivity sample is self-registering on startup. So if we go now to the GraphQL endpoint and we ask for the applications, right now I just have the demo, but if I run this again, we can see now that the connectivity sample is listed. And if we go to Management Client and we refresh the UI, it should also appear in here. And we have it here, connectivity sample. All right, now let's see how to install the connectivity sample through Docker Compose. But before doing that, let's just review what happens when the application runs on a Docker Compose network. That will imply that the average and the connectivity sample are both running within the same Compose or Docker Compose network, and thus the endpoints for the query, streaming, and broker, they do not to be publicly available outside of this network. So let's now see through the example. So in the clone repository of connectivity sample, there is already a docker-compose.yaml file with all the definitions needed to run the application and to pull it and install it as a Docker composed app. So in this machine, I'm running the same AI bridge, and now I will run the connectivity sample. Since both the AI bridge and connectivity sample are running with the same network, which is called AI bridge underscore default, they will be able to connect to each other through the Docker Compose internal network. So in order to install this application, just go to the root of the application connectivity sample and just run Docker Compose up -d. It will pull the Docker image from ECR, and if I do the lazy Docker that I have installed in this machine, in the logs, I will also be able to see the registration succeeded. Again, if we go to the app, to the query, and I ask for the applications, we can see here the connectivity sample has been installed. And if we go to management client, I'm just refreshing, and we go to the AI bridge connectivity sample, it's also here. All right, now let's see how can we install the connectivity sample on a Kubernetes cluster. For that, we have provided a Helm chart package that can be obtained from the public ECR repository on AWS. And if we go to the public repository on GitHub, we will see under Helm folder that there is this README file with all the instructions that are needed in order to install the Helm chart package. We are going to go through them in this video tutorial. So as you can see from the beginning of this documentation is that we are going to pull the Helm chart package from the public repository. Then we will untar the file that we get, the Helm chart package, and then we will navigate inside of the connectivity sample folder that gets created. I've basically just do that some moments ago. So I pull, I untar, there is this connectivity sample folder. So if we navigate now, we will see a list of files. And in here, there is this file called values.yaml. This is the file that we need to adjust depending on our Kubernetes cluster. So when we go to this file, I've already modified the mandatory fields that needs to be adjusted, and those are the external host name. This is the host name where the Kubernetes cluster can be reached. The external IP, this is the IP, that address of the Kubernetes cluster where it can be reached. Then it's also worth to mention the property TLS enable, and this property must be set to true in case the AI bridge is running also on secure mode. Since we are running AI bridge not using certificates, I will also run the IVA application without certificates as well. So once this application has been downloaded and we have edited the values.yaml file, we are now ready to install the application. By going to this documentation, we will find here the Helm install command. So I will run the Helm updates and then the Helm install command. And as you can see, it's going to be run in the same namespace that we installed the AI bridge, and that means that it will have access to the same information or objects that were deployed within the AI bridge. And this is what we also strongly suggest you to do in your IVA applications. So now that we run the Helm install, as we can see now, it has been deployed, and that means that there must be a pod already running in the system. So let's see that. Let me clear the command. So kubectl get pods. We are going to white them up to have a proper look, and they are in the AI bridge namespace. Whites, it's -O, sorry for that, to expand. And as we can see here, there is this connectivity sample pod running. So now let's also check the logs of this pod to see if the application has some error. So kubectl logs of this namespace, and bridge, and now the name of the pod. And as we can see from here, the application says that it has registered successfully. So let's go now to the query and see what do we get. We didn't have any application on this cluster. If we run the query again, we have now connectivity sample. And last but not least, let's check on the management client application. I will refresh management client. And in here, we see that we have connectivity sample already registered. So that means that the connectivity sample has been deployed on Kubernetes using our Helm chart package. Let's check now through a quick demo what this application exposes in this version 1.0 and how can we interact with it. So when we navigate to this AI bridge and we have connectivity sample installed or registered, we see immediately that by clicking on it, we expose this idea of a landing page for the application. This could be useful in case we want to show aggregated information or a dashboard, for instance. It's also worth to mention that this application comes with two topics. One topic called Get Snapshot, just to showcase how we can get a snapshot from a camera. And in this page, when clicking on this topic, we can also set configurations that are related to a specific topic. So this is, again, an optional page and it's an extensibility point. Then for this application, when we navigate to a camera, for instance, in this camera, and we go to the processing server tabs, we can see here that we have two snapshots, two topics. One, it's called the get snapshot, and this one is basically getting a live snapshot out of the camera. This could be useful when configuring a topic and, for instance, trying to select a region of the camera that we want for analysis. So using the snapshot functionality could be highly useful for that scenario. Then we also have this Send Analytic event. This is, again, an event topic. And when we subscribe to it, we will be able to start sending analytic events to the VMS. Also, because we have subscribed, it's already created. I'm going to refresh a smart client, management client. And now we see that we have connectivity sample sending analytic events. So that came because we subscribed to the topic. And when we click on this application, we get this HTML with this start button. And when we click on it, this application will be sending or mimicking sending events from this, let's say, based on this camera. So if we go now to Smart Client, we are going to see here these events popping up every 1 or 2 seconds, actually every second. So it's going to be mimicking the sending of events. In this case, we are also including an image as part of the event. And obviously, when we click on the stop button, it will stop the functioning. This IVA application also exposes or shows how to register itself from on AI Bridge. And the last but not least, in order to unregister this application, it's as simple as going to the management client, the list of registered applications, and clicking on unregister. That shows how to interact with the connectivity sample and the capabilities that it offers today. We plan to extend this application moving forward to showcase the injection of metadata and video, as well as other functionality. Now that we have seen how to install and how to unregister the application, it's time now to discuss how to uninstall it. From an uninstallation point of view, the principle is the same as with AI Bridge. If you're running on a Docker Compose installation, you just need to run the Docker Compose down command, and then if needed, removing the local Docker images that were pulled. If you are running on a Kubernetes setup, it's as simple as running the helm uninstall command, as you can see here. Thank you all for tuning in. Wishing you a great day.